All right, welcome to Good Choices. I love saying that because, yeah, this is a good choice. If you want to do well in your career, um, sometimes you just got to go above and beyond. And especially at this kind of moment where it seems like there's a lot, there's all these layoffs in the field and everything. Yeah, you got to put in some extra effort sometimes and just make the right choices. So let's continue doing that. Um, last video, I talked about this energy drink. I've kind of always had problems with like ADHD, so like I haven't been making these videos consistently. So any edge I can get on that that doesn't have significant trade-offs, I'm gonna try. So I'm having this energy drink again this morning, about 3/4 of the way through it. Just recently had it, so it probably hasn't even kicked in yet. But yeah, my sleep was great last night. Didn't seem to interfere with my sleep at all, so that's good news. I really need some sort of aid like that. All right, so last video we finished up lesson 102.3, which is managing shared libraries. Yeah. And there was a lot of new content in that. So I remember some things about it. I remember that a shared library is not a static library. I remember that executables have dependencies, and a lot of the times those dependencies are shared libraries. I remember the naming syntax for a shared library. They usually start with a prepend lib and then the name of the library and then .so and then the version of the library. And that's about it. I don't remember much else. So I am going to go and kind of look at some of the exercises I did so that I can relive my traumas time and time again. So actually this should be pretty good. So like, what directory do new shared library directories go on your system? And that's the other thing that's kind of confusing about this. Is like a shared library and a shared object are like the same thing. Like there's duplicate naming, which makes it a lot more confusing. But if I remember, it was like, yeah, now I know it's .d. That's the tricky part. It's like something like ld.so .d, something like that. Let's refresh quick and look at the answer. ld.so.conf.d. Hey, I think I was exactly right. And then the next one, what command should you run to make the changes fully active? ld-config. And what does... I feel like this ld here is a really key thing. So let's try to get like an answer for what this ld could stand for, because that would make it really easy to remember this. Okay, so we can always ask the AI. Let's do that. Okay, so we're gonna highlight that, click the, and again, this is an extension I mentioned in earlier videos. I can mention it here because I understand if people don't want to fish through an old video and they're just watching the beginning. Chat GPT box for Chrome is the extension, so just type in Chat GPT box. And it's this one here, really easy to install. You just add it to Chrome. I don't have it added to Chrome, it looks like, so maybe this is not, in fact, the extension I was using. Oh, so yeah, actually that wasn't it. It looks like there's two of them. There's one with a dash and there's one without a dash. So I'm not sure which one is better. You can try either one, but I am using the one that does not have a dash. Okay, so here's what it says automatically about that command. Let's ignore that, and we're just gonna say, what does LD stand for in the command name? Ah, perfect. So this is kind of, I figured that the L stood for linker. The D, I was not so sure. Maybe like directory or something like that. But in the command name ldconfig, the LD stands for linker directive. The LD portion of the command is derived from the name of the GNU linker, which is a program responsible for linking object files and libraries together to create an executable or shared library. The linker plays a crucial role in resolving symbols and establishing the necessary connections between different components of a program. In the case of ldconfig, the command is specifically related to the linker's configuration and management of shared libraries on a Linux system. It updates the necessary runtime link bindings and ensures that the system recognizes and uses the correct versions of shared libraries during program execution. Okay, so I want to know why. So the okay so okay LD stands for linker directive. Why? What significance does the word directive play? Yeah. All right. So in the context of the LD config command, the word directive refers to an instruction or command, makes sense, a direction, a directive, that provides guidance or specific instructions to the linker. A linker directive is a special command or statement used within the linker's configuration files or command line options to control its behavior and perform specific tasks during the linking process. In the case of ldconfig, the directive is used to update the runtime link bindings of shared libraries. It directs the linker to update the cache and establish the necessary links between the libraries and the programs that depend on them. By running the ldconfig directive, you are instructing the linker to update its configuration and ensure that any changes made to shared libraries are fully recognized and effective in the system's runtime environment. In summary, the word directive in the context of the ldconfig command emphasizes that it is an instruction or command given to the linker, guiding it. So linker directive, which makes sense. You know, this is a command to what does the command do? It updates everything so that your shared library goes live. So it's like, you know, it's makes it so that the directives of your linker, you know, it's directions for your linker basically. So the command emphasizes that it is an instruction or command given to the linker, guiding it to perform a specific action related to the management of shared libraries. Perfect. Now I want to do one kind of maybe galaxy. Oh, you know what? I want to review the next one. I see the answer there, but I don't see it super clearly. So what command would you use to list the shared libraries? I don't remember, just based on what I see there. So I'm pretty sure it's a -p command. I don't think it's necessarily cheating to look through my history to find it. That in the real world, you can rely on your history quite a bit. So there it is. ldconfig -p kill. Which kill ldconfig. See, and this is learning here. So like I remember how to Like, knowing how to know is way more important than knowing. There we go. Which, I mean, is knowing in a sense, but it's knowing. It's like the dynamic library versus the static library. You're knowing something dynamic instead of something static. Like, dynamic knowledge is far more powerful than just static knowledge. Although sometimes static knowledge is like important because it can make it so you don't have to go through that dynamic process and waste time on something like what's 5 times 4, it's 20. I shouldn't have to go, oh well, break it down, 5 times 2 is 10, and then there's a remaining, then you can double that because it's not 2, it's 4, and you get to 20. That's a dynamic knowledge that just wastes time for such a simple question. Okay, so yep, that looks good. And then I remember this gave me issues last time, so let's take a look at my history and see what that looks like. So yep, I needed to know the yep. So I needed to print the dependencies of GLIBC, so the GNU C library. So I needed to magically know that and you know what? Shoot. I'm pretty sure like GLIBC shows up somewhere. I forget how I knew that GLBC was this. I know that there were commands where like you could see like GLBC was just a symbolic link and like the real thing was that. So I'm going to go through and try to find that. Yeah, so this is a a symbolic link. So GLBC, GNU C library, is a good example of a shared library. On a Debian Linux 9.9 system, the file is named libc.so.6. Such rather general file names are normally symbolic links that point to the actual file names containing a library. So yeah, unfortunately GLBIC is not really used anywhere. You just have to know that it's kind of the common name for a it's kind of like nothing is actually called or like a good example. I don't know what a good example is, but it's just kind of a idiomatic name for these files here. All right, so we did that here, and then we learned that I guess the most important one is we were able to figure out the dependencies of Bash. So like if you're on the job and things are just completely busted and you're a Linux administrator, you probably need to know this, because one of the first things you can do is check for dependencies of Bash, and if you are missing dependencies, that's probably what you need. So you can do pipe grep needed. So we need these here for Bash. So then you can go, I think, find, or you can go which. Now, I think which only works on executables. I'm confused. I want to move on from this. I've been spending too much time on this. So yep, let's do that. All right, lesson 1. topic 102, which is Linux installation and package management, and then objective point 4, which is to use Debian package management. Now, I'm using Ubuntu, but we will see. I can always spin up GNS3 and load up a Debian machine, a virtual machine, if I need to. Yep. All right. Introduction. A long time ago in a galaxy far, far away, when Linux was still in its infancy. Sorry. Sorry. I have to keep it together here. Maybe take some more of my chemical drink. There we go. Chemicals. The most common way to distribute software was a compressed file, usually a .tar.gz archive with source code, which you would unpack and compile yourself. However, as the amount of complexity and software grew, the need for a way to distribute pre-compiled software became clear. After all, not everyone had the resources, both in time and computing power, to compile large projects like the Linux kernel or an X server. Okay, so it used to be that you would distribute software as a compressed file, and then you would unpack it and compile. But that to the act of compiling software adds a lot of time and requires a lot of computing resources. So as the size and complexity of software grew, one of the major advances in computer technology was being able to distribute pre-compiled software. After all, not everyone had the resources, both in time and computing power, to compile large projects like the Linux kernel or an X server. Soon, efforts to standardize a way to distribute these software packages grew, and the first package managers were born. These tools made it much easier to install, configure, or remove software from a system. One of those was the Debian package format, .deb, and its package tool, DPKG. Today, they are widely used not only on Debian itself, but also on its derivatives, like Ubuntu. There we go, we got it. And those derived from it. Another package management tool that is popular on Linux-based systems is the Advanced Package Tool, APT. So sudo apt-get, those sorts of things, is a package management tool, as is DPKG. But the package management tool apt, which can streamline, so another package management tool, okay, I'm going to just start here. Soon, efforts to standardize a way to distribute these software packages grew. Okay, so to distribute large projects that were already compiled, saving you the time and compute power to compile them yourself. So a way to do that was through a package manager. And the first packager, and they make it easier to install, configure, or remove software from a system, and you don't have to waste time and computing power compiling them yourself. Instead, the package manager has super magical powers. One of those was the Debian package format, .deb, and its package tool, DPKG. Today, they are widely used not only on Debian itself, but also on its derivatives like Ubuntu and those derived from it. So let's take a look at my home lab, see if this is a valid command. And it is. It's just it needs to be fed an action. Another package management tool that is popular on Debian-based systems is the Advanced Package Tool, APT, which can streamline many of the aspects of the installation, maintenance, and removal of packages, making it much easier. In this lesson, we will learn how to use both DPKG and APT to obtain, install, maintain, and remove software on a Debian-based system. So the classic apt command, sudo apt update. Very important command. Okay. There's no apt get update. Is that why it's now? Okay, something. Well, hey, maybe I'll be able to fix it by the end of this learning material. So the first Debian package tool we're going to learn about is DPKG. The Debian package DP, I don't know what the P stands for. It stands for package. Okay, so DPKG, Debian package. The Debian package DPKG tool is the essential utility to install, configure, maintain, and remove software packages on Debian-based systems. The most basic operation is to install a .deb package, which can be done with dpkg-i package name, where package name is the name of the .deb file you want to install. I'm not sure what -i is. Let's take a look. So we'll do a dpkg -help. And I misspelled it. dpkg -help. Alright, taking a look for the -i. I see an uppercase I. I do not see a lowercase yet. Install. Package updates or package upgrades are handled the same way. Before installing a package, DPKG will check a previous version already exists on the system. We'll check if a previous version already exists on the system. If so, the package will be upgraded to the new version. If not, a fresh copy will be installed. And I need a quick break before we deal with dependencies. We might need a intervention or something first, but I'll be right back. All right, I'm back. I had my intervention. All my family gathered around, long lost friends I hadn't seen for a while because I've just been so, not myself lately with everything I was dealing with, all my dependencies. So let's learn how to deal with those dependencies now that I'm in the mindset to actually make real changes after my intervention. So sorry, I can't keep it together. More often than not, a package may depend on others to work as intended. For example, an image editor may need libraries to open JPEG files, or another utility may need a widget toolkit like Qt or GTK for its user interface. DPKG will check if those dependencies are installed on your system and will fail to install the package if they are not. In this case, DPKG will list which packages are missing. However, it cannot solve dependencies by itself. It is up to the user to find the .deb packages with the corresponding dependencies and install them. In the example below, the user tries to install the OpenShot video editor package, but some dependencies were missing. Alright, as shown above, OpenShot depends on fonts dash can cantarell, Python 3 dash OpenShot, Python 3 dash pyqt5, Python 3 dash pyqt5.qtsvg, Python 3 dash pyqt5.qtweb qtwebkit, and Python 3 dash zmq packages. All of those need to be installed before the installation of OpenShot can succeed. So let me try to use this command. And I kind of don't want OpenShot on my home lab, but I'll try it anyway. I'm just never going to use it. It's going to hog up space. But hey, this is a learning opportunity. If it gets on there, then I can learn how to uninstall. Okay, so this is it can't find the no such file or directory. So that's interesting. I mean, we've seen in prior examples that this is like particularly like pretty darn out of date. So maybe this version has been discontinued and is no longer exists. Alright, so removing packages. To remove a package, pass the -r parameter to dpkg, followed by the package name. For example, the following command will remove the unrar package from the system. dpkg-r unrar. Okay. The removal operation also runs a dependency check, and a package cannot be removed unless every other package that depends on it is also removed. If you try to do so, you will get an error message like the one below. So dpkg-r p7zip. I don't want to do this on my system. Just, if it bricks things, then I gotta spend hours and hours troubleshooting and fixing it. And my system works, unlike a lot of other home labs. So I'm gonna skip doing this in my home lab. You can pass multiple package names to dpkg-r, so they will be removed at once. When a package is removed, the corresponding configuration files are left on the system. If you want to remove everything associated with the package, use the -p purge option instead of -r, which stands for remove. Note, you can force dpkg to install or remove a package even if dependencies are not met by adding the --force parameter, like in dpkg-i-force package name. However, doing so will most likely leave the installed package or even your system in a broken state. Do not use --force unless you are absolutely sure of what you are doing. Okay, so you should not use this because you can remove it. You can install or remove it, even if it doesn't have the. So, like for installing, of course, that's intuitive. You'll install it, but you won't have some of the dependencies, so it won't work. You're just hogging up space for a program that doesn't work. So, like, maybe there's some reason if you're a developer you'd want to use that, but typically, if you're not absolutely sure what you're doing, do not use --force. Getting package information. To get information about a .deb package, such as its version, architecture, maintainer, dependencies, and more, use the dpkg command with the -i, uppercase I, parameter. That's to get information, as we saw in our help menu when we did -help here. Followed by the file name of the package you want to expect. So dpkg-I. This is a Chrome. Let's see if this exists. Now this is a -I command, so it's kind of like a show command on Cisco. It's not going to brick anything, hopefully, unless there's a bug, which there's always a bug. So, oh, I think we need sudo. No, okay, so yeah, I don't have that package. Let's do a help on dpkg-help. And let's try to see what packages I have. Okay, I do not see. Get a list of selections. Display. Oh, here we go. So -L maybe, list packages concisely. Let's try that. All right, sweet. So here's all my packages. Some packages are bigger than others. My packages are the big. No, just kidding. Okay, so here's one I think is the most appropriate for this channel, Wireshark. So let's get some information on that. We're gonna do dpkg-I. We're gonna do pkg-I and Wireshark. Okay, we failed to read it, so that is not the package name. That's just so we've got some columns here. Okay, so we've got the name, the version, the architecture, and the description. So maybe we need to feed it the architecture. Let's take a look at the help on the dpkg-help. I have trouble. PKG, I have trouble typing that out. Okay, so the -I, uppercase I for info. I do not see on here. Just do a grep on that because that's all we need to look at. Oh, you know what? It's okay. If I put it in quotes, it should be fine. Oh, no. Okay. Why is it dash? That's interesting. So it looks like I actually can't. Oh. There is no -I option? Oh. Okay, actually it looks like it's at the top here. Okay, yeah, so here it is. Validatable things. The package name, the architecture name, the trig name, and the version. So we can use this here. So we got the -I here for info. So package name. So it says that the package name is validatable, but as far as I understood, the package name was Wireshark. Yeah, so this should be the package name. Let's try with Python. So instead of getting info on the Wireshark package, let's get the info on the Python package. Same issues. No such file or directory. Oh, you know what? This is the problem. So we got to do which Wireshark. There we go. And now we can do dpkg dash uppercase I user bin Wireshark. Oh, it's not a Debian format archive. Okay, so we'd have to use probably the apt for that. let's see if we've got a .deb. So I'll run this command again. Forget what command that was. It's the command to list out all my packages. So dpkg-l pipe grep, and then let's see here, grep, and I'm looking for deb. Okay, so what about this Python 3-Debian? Is that a Debian package? I'm guessing not, because if it were, this would be simpler than it is, and this is not very simple. So let's do a which on that. Okay, so I guess it's just there, and then let's do a dpkg uppercase I. Right, no such file or directory. Okay, that is confusing. Yeah, I'm very confused. I don't know why I can't do this. I don't know what to feed this. So I do notice that we've got different we've got AMD 64 architectures, and then we've got all architectures. And then I think there's a third one. I thought I saw a third one. I do not see a third one. Oh, I do see a third one. There's i386 as well. So let's try an all one, because I think that will work. Nope. 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 Oh. Now why does which sometimes here, let me ask my personal tutor. So in Linux, and I don't need to spend ChatGPT 4 credits for this, why does the locate command sometimes work when the which command does not? Okay, so the locate and which commands in Linux serve different purposes and have different mechanisms for finding files and executables. The which command is used to locate the executable. Okay, there we go. The executable associated with a given command or program. It searches for the specified command in the directories listed in the system's path environment variables. It essentially checks each directory in the path to find the first occurrence. Okay, so the difference is where it's searching. Which searches based on your environment variables, and locate searches based on a pre-built database of files on the system. So like basically if you want to look for files or folders specific to your like user profile, you use which. But if you want to look at them just based on, like, if you want to search the whole system, use locate. If you want to search things just relevant to your particular section, then use which. That's how I understand it. Let's see what the manual says. Which tasty. And it's almost lunchtime. Well, it's always almost lunchtime. Okay, so locate a command which returns the path names of the files which would be executed in the current environment. And let's see how that's different from locate. Locate reads one or more databases prepared by update DB and writes file names matching at least one of the patterns to standard output. So it's the difference between your particular like user profile. Where is this? It's not associated with that. Versus the whole machine. So where is it on the whole machine? It's under /share, and then it's in var/lib. It's not under user gpush. All right, so let's see if we can feed this in. So let's see here. dpkg dash first case I fqdn, and I have a really hard time typing in pkg for some reason. Okay, so I feel like I'm getting closer here. I got to a directory now. Let's see what's in that directory. Okay, so we've got a change log. Maybe I'll try that. Okay. Okay, it's not a Debian format archive. So okay, let's do this. How do I find a Debian format archive on my system? All of my Debian format archives on my system. Okay, so these are .deb files, so you can do find along with the file command to filter and identify files. So here's the command you would use. Looks pretty darn complicated. Let me try to explain it myself. Whoops. Okay, so find, and then so the slash, so it starts searching from the root directory. You can replace it with the more specific directory, save time if you kind of have some sense of where it is. And then -type f indicates we are only interested in files, can ignore a match for a folder. --name star.db -exec file open close brace /:colon executes the file command on each file found. The open close brace is a placeholder that represents the found file, and /. So is it executing the file? It executes the file command. Okay. Oh, I think this is how we can tell whether it's a file or not. But I thought we had the type F. I thought that would do that. Let me ask the AI, why do you need... So I'm going to ask it why it needs... Why is part 4 needed? I thought the -type F part 2 already made it so that we're only getting files. Okay, so in some situations, the files may not have proper file extensions or may be mislabeled. The purpose of -exec file, open close brace, /; part is to invoke the file command on each found file and obtain a more reliable identification of the file type. Perfect. This is why I love the AI. So let's do a file on Python. So let's do a which on Python. Okay, and then a file on user bin Python. There we go. And we can see it's a symbolic link. So let's get the to Python 2.7. So let's do the same thing on 2.7. There we go. And now we can see so much more information about the file. So that makes sense to include. All right, so let me just run it here. Permission denied. Okay, now we've got some binary packages. Okay, so now I can run it. There we go. Now we've got some info on a binary package because we're feeding it an actual binary package. We found the binary package using the find command, and then we started searching from the root directory with a slash. Then we looked for only files with the dash type F. Then we looked for only files with the file extension .deb. And we made sure to find files that were named incorrectly that were still Debian files with the dash exec. And then we did the file command. So we executed the file command on them. And then forward, open, close, paren, backslash. I'm not sure how. Oh yeah, and if it was. Okay, so I guess we did the file command. So the file command examines the file's content and provides a more reliable determination of the file type, regardless of its extension or potential mislabeling. Using this additional step, we ensure that only files identified as Debian binary package are included in the final output, including that part provides an extra level of verification to ensure that the found files are indeed Debian format archives, even if their extensions or labels are not explicitly limited to DEB. Okay, so let me get this straight. The exec portion will determine if a file named .deb is not actually a DEB file, but it will do nothing to determine whether a file without .deb is actually a DEB file, because the prior dash and name portion of the command narrows the results down to only include files named .deb, whether they are actual .deb files or not, which we determine using exec. Correct? I broke it. I broke the AI. Okay, I've done that quite a bit. I actually tried to play chess with it, and it kept like adding pieces to the board. Like, what the hell? Oh, okay. Sorry, I added water to my energy drink can, so I felt like I even though I drank the whole thing, I magically had more in it, which I did, but it's just water. So I broke the AI as usual. I break the AI quite a bit. I think that's right. So I'll just move on to the next part. Listing installed packages and package contents to get a list. Oh, well, shoot, of every. Okay, well, every package installed on your system. Use the dash dash get selections option, as in dpkg dash dash get dash selections. You can also get a list of every file installed by a specific package by passing the dash L package name parameter due to dpkg like below. So I guess I'm just blind. I didn't see that option when I looked through the help. Dpkg dash dash help. And then it's the, what is it, dash dash get or like dash get? I don't even know. Yeah, get selections. Okay, I've thought about doing that one, but and then I can feed it a pattern. I'm not going to do that. Okay, yeah, so here we go. Here they all are. So let's try it with tree. Which tree? Okay, and then dash I user bin tree. But it's not in Debian format. Okay, well, I guess it just shows me all my packages, whether they're in Debian format or not, and okay, which is annoying. All right, next, find out which package owns a specific file. Sometimes you may need to find out which package owns a specific file in your system. You can do so by using the dpkg-query utility, followed by the -s parameter and the path to the file in question. There it is. Let's see if I have this non-free. I don't think I do. Nope, I don't. So let's try it with usr bin tree. There we go. And wait, how is this useful? Oh, I guess it's not owned by. Oh, okay. So I guess you can do it without. Um, Yeah, if you don't feed it the FQDN, it will show you basically like all of the FQDNs. Sorry, it's not an FQDN. If you don't feed it the path, FQDN is a fully qualified domain name, so kind of like a URL. But this is not that. This is just a path. So yeah, if you feed it the specific path, then you're not going to get any good information. But if you just feed it the name of the file, then you can see all the packages. So like here's good. Like you can get the package name. So like this, the file is, so like if we take one of these files, like even just like the man file, and we don't know what the name of this is, we can see it. I mean, we see it there, but like let's try it with Python. Okay, we get a bunch of stuff. Oh, I don't see how this is useful, because if you already know it, you don't need to know it. So let's ask the AI. Okay, so how is this command useful if you already know the -s parameter to feed to the command? Why? And the command just returns that same parameter back, what use is the command? Okay, so you raise a valid point in the specific example provided where you already know the file path and you use the dash capital S parameter with dpkg-query. The command does indeed return the same parameter back. However, the dash dpkg-query dash capital S command becomes useful in scenarios where you don't know the package that owns a specific file. By providing the file path as an argument to dpkg-query-s, the command searches through the installed packages and determines which package claims ownership of that file. This can be particularly helpful in the following situations. Troubleshooting: if you encounter an issue related to a specific file, knowing the package that owns it can help you identify and resolve the problem. You can then investigate further by checking the package's documentation, updating or reinstalling the package, or seeking assistance from the package maintainer or the community. Dependency management: understanding which package provides a particular file can assist in managing dependencies. When you need to install or remove software that relies on specific files, you can ensure that the required package is present or remove it without breaking any dependencies. System maintenance: as part of system maintenance or cleanup, you may want to identify orphaned or unused files. By using dpkg-query-S, you can determine the package associated with a file and decide whether it is necessary to keep or remove it. In summary, while the specific example in the content may seem redundant, the dpkg-query-S command is valuable when you need to discover the package ownership of a file, which can aid in troubleshooting, dependency management, and system maintenance tasks. The AI is wonderful. What a world we live in. Alright, next section, reconfiguring installed packages. And this looks like a particularly long section. It could just be that I'm taking forever to read it, but it looks like this bar here is very long. So I'm gonna have to split this up into multiple parts. It looks like. What am I at now? I'm about at the hour mark. So let's get through all of the DPKG reading, and then before the APT section, I'm gonna take a break. And if I'm not feeling it, I might split it into a part. If I'm feeling it, I'll see how much further I can get. So reconfiguring installed packages. When a package is installed, there is a configuration step called post-install, where a script runs to set up everything needed for the software to run, such as permissions, placement of configuration files, etc. This may also ask some questions of the user to set preferences on how the software will run. Sometimes, due to a corrupt or malformed configuration file, you may wish to restore a package's settings to its fresh state, or you may wish to change the answers you gave to the initial configuration questions. To do this, run the dpkg-reconfigure utility, followed by the package name. This program will back up the old configuration files, unpack the new ones in the correct directories, and run the post-install script provided by the package as if the package has been installed for the first time. Try to reconfigure the TZ data package with the following example. Okay, let's try it. It'll probably fail because I don't have that package. Have to have root. Oh, okay. Here we go. We're doing it. So I'm gonna cancel this because I'm scared of what this is. And as I said, my home lab works, which is very rare in this space. So I don't want my home lab to no longer work. All right, so I canceled it. Ooh, you know what? This is kind of what I need. You know, this is time zone data. Oh, you know what? Yeah, this is to change my time zone. I want to do that because the default time zone right now is etc-UTC, and it thinks that the local time is 15:57 UTC, and that local time. I think that's a 3 p.m. So yeah, you know what? Let's do that and change my time zone. Okay, so my time zone is the U.S. and then the city that corresponds, or within the U.S. My time zone is Central Time. There we go, and now it's accurate. Oh, thank you. I needed that. Cool. That's good. You know what? I think I am gonna split this into multiple parts because this APT is a really, I think, important, relevant section. So I want to have this all contained within its own video because this is what really matters. I think this is what will be used more often in the real world, I believe, or is relevant to most of people who would want to watch this. Is probably going to be this. So I'm going to end this here at the 1 hour mark, which is a good mark, and stay tuned for the next video on APT.